Hello, I'm Kirsten.
And I'm Nicholas. Welcome to the Anthropo Scene.
All right.
God, that's new.
I know. I noticed that the other day. I don't know if listeners can hear it, but there's now a recording in progress thing. And I think it's to make people extra aware that they are being recorded for like legal purposes. But of course,
whatever.
It's like
if you're on webcam, you're getting recorded anyway.
I know. But for like repurposing, if it's like an organization or something. Yeah. And if you're not the one recording, you have to click continue and say that you are like, what's the word?
Aware that you're being recorded.
That you're accepting. Well, that was a hard word.
Right.
You're accepting the terms of being recorded. There's another word though, not complying, but anyway.
Right. Well, it's so that I know that if somebody can see that I'm not wearing pants, then it's going to be recorded for future use. So
I guess. All right. We may or may not cut that sidebar out. Hello, everybody. I'm so excited that we are here again for another Anthropo Snip. We had a little break just because Nicholas and I got pretty busy with some of our other jobs. I say jobs with an S for real life for both of us. But now we're back.
Yeah, and then we're done.
Hey, don't tell them that yet. Yeah, a heads up, people. I think we're going to be taking a break between season 1 and 2 for the summertime, but that gives everyone a chance to catch up on episodes they haven't heard yet and gives a chance for people just to get outside and enjoy it. And then once the weather starts getting colder again for everyone in North America, then you guys can start listening again to the episodes. It does actually rain here like quite a bit in Quito in a couple of the winter months. So
I don't want to hear it. I don't want to hear any of it.
Indoor time.
Within this tropical paradise, sometimes it's wet. Whatever.
Hey, I'm in the Andes and it gets pretty cold. Okay, like you'll see, I'm always in a scarf.
Right. And of course, if we have any extra time and we can fit in an extra snip or an episode or just some bonus content for you guys, we'll definitely do that as well. I don't think it's going to be like a just, you're not hearing from us. But of course, we're both very active on our regular social media. So if you want more of us, you can definitely get information that way. We don't stop communicating science. We just stop for a little bit from this forum because we are busy doing our main jobs, which are very, very busy when it's, the growing season and things like that. Or if you live in the tropical epicenter of the world, then you're busy year round, hypothetically speaking.
If I was actually doing biology work right now. But anyway, I am doing my biology work through this lovely SciComm, and I wouldn't have it any other way. Anywho. All right, so we started out a bit of a tangent today, but we thought we'd let everybody know about a potential pause coming up. But on other note here, today I'm going to talk about an ecology topic that I am super interested in and I've always really loved. So we are talking today about wildlife crossing structures. So you might have heard these as animal bridges or animal overpasses, underpasses, and these are things that help wildlife of all shapes and sizes, from crabs all the way up to megafauna like elk and other things, and predators like wolves, jaguars, to get under or over really busy highways and things and help remain their connectivity in the environment. Because as we all know, highways are a huge obstacle to wildlife crossing. And then the other reason that it's kind of interesting is the human aspect, like for the money that it costs for repairs and things, and also human mortality. There's tons of really horrible accidents with wildlife crossing highways and things like that. Nicholas, have you ever seen any, in person, any animal bridges or wildlife crossings?
Yeah, we actually have quite a few around here in our conservation districts and stuff like that. It's actually specifically designed for like herpetofauna usually. Most of the time it's turtles specifically. We have a bunch of like turtle bridges, turtle tunnels, and things like that. Not so much bridges, I guess. They're pretty much all tunnels. And they're mainly when they go over railroad tracks or something like that. They'll go underneath the railroad tracks because not only is it dangerous for a turtle to try and get over railroad tracks, it's almost near impossible being that they have the shell. If they're not a big enough turtle, they can't climb over those tracks. So they basically are, it's like a massive wall to them that they can't surmount to get to the neighboring and adjacent habitats. So it's a means of not necessarily reducing fragmentation, but allowing access to equally fragmented habitats so that they can cross between those two areas. That being said, I'm interested to see what you have today because in my experience, or not necessarily in my experience, but in my research, just things that I've been looking at, I've seen a lot of like, or not a lot, but a few studies that have cited that animal bridges just don't work for certain species. Like they just ignore them and they continue to cross the regular road because, you know, an animal's not going to see a bridge the same way a human does. It's going to be like, what is this anthropocentric structure? I probably should stay away from that and then cross the road and still get hit.
Mm-hmm. Exactly. So, yeah, there's a whole bunch of really cool things about it. Of course, my first kind of encounters with wildlife crossings are the ones in Banff, which are some of the most famous, which I'll talk about a tiny little bit. They were some of the first kind of pioneering animal bridges for, especially for larger animals. And yeah, what we're going to look about a little bit today, like you mentioned, there's definitely some research missing. There's some gaps. There's some issues with species specific problems and how effective they are. So we're going to talk just a little bit about that today. We can't get into every single piece of it because it's a pretty complex topic, but to try to cover a very complex, wide topic, I have found a meta-analysis from, sorry, cut that out. Yeah, from this year, from 2021. That is actually looking at, the name of the paper is Factors Affecting Usage of Crossing Structures by Wildlife, a Systematic Review and Meta-Analysis. So before I dig into that paper, what is a meta-analysis and why is that a good thing for reviewing a topic? So essentially the authors of the paper take data from a bunch of other papers, people that have done their own research in different areas, and they use all of that data together so that they can do analysis on more data, essentially, and try to draw some broader, more general conclusions about something that's been studied in like smaller areas, right? So it's a super cool method because it takes a lot of data, which would be super hard, if not impossible, to collect as one group of scientists. And then it comes out with some neat results and helps look at how much a certain principle might apply across like broader habitats and situations. Now, of course, this also leads to some troubles with consistency on how things were collected, on if this general result is going to apply to more individual habitats. But the authors of this paper look at that really well, too. So we'll get into that. Nicholas, anything to add on meta-analysis before we head on?
I was just going to kind of briefly describe it as like a synthesis or a meat. If you guys have ever done any sort of research paper in high school, you know, or college or university or whatever, it's essentially that, but on a larger and more professional scale. A research paper in college essentially has you taking all of these cited different sources and things like that, generally peer-reviewed sources, and you're synthesizing them into something that could potentially make new conclusions. However, the differences between most research papers and like a meta-analysis is a meta-analysis will actually use statistical analyses and things like that, not just to hypothesize conclusions, but actually create statistical correlations and look at the information in more depth. So it's like what research papers prepare you for in the real world.
All right, so it's like a literary review or literature review, but you're using the actual data and doing actual stats on data from different scientists. So it's I think it's a really interesting type of research, and I think it's really important to try to draw some general conclusions. And what we're going to see with this paper is to kind of, more so than draw conclusions, to help point out what's missing more so in between different studies and between like all the different results and conclusions that we have. So anyway, this paper is by Denneboom et al. 2021, and it's called Factors Affecting Usage of Crossing Structures by Wildlife, a Systematic Review and Meta-Analysis. Now, before I read this paper, I decided to jot down why should we care, right? And then kind of see what it lined up with this paper as well, just because I've always been interested in wildlife crossing structures, which can also be abbreviated to WSC if we're feeling cool. So they're super important for helping saving animal and human lives, as well as money. So collisions with animals are a huge cost to clean up, to deal with for people with injuries. And then obviously the big part is the conservation aspect. Animals that are being killed on the road, whether they are endangered or not, this is harming the population and this is causing a ton of problems. And we don't want animals to be dying on the highway. Like that's just kind of the easy in a nutshell why we should care, right? But we need to find ways to make them more effective, right? Because as Nicholas said, a lot of the research shows that, a lot of the animals just go around them anyway, or they don't use them. And unfortunately, we can't just have a big neon sign that says, hey, deer, like come cross over here. It's safer. So what we need to do is we need to make it attractive to cross, make it safe, eliminate these problems. And also, if you've ever seen like some of the big wildlife crossings or under crossings, or if they have fencing and things around that, this is a lot of infrastructure and a ton of maintenance, right? So it's money, right? So if we're going to be spending all this money on this infrastructure, it needs to be backed by research so we know how to do it effectively. Because if you're just spending, like throwing a bunch of money onto the road, trying to make these crossings and it's not working, then it's just a big waste, right? So, a meta-analysis is kind of a way that hopefully we can find a way to narrow down what are some of the more effective strategies to these, and then find a cheaper and most effective way to do this.
Yeah, I mean, I think too, part of it is going to be, is it an effective means? Because we think of everything in like a monetary value. It's very difficult for us to just assign a value to like an animal and conservation unless it comes back to us for some reason. So a lot of it's going to be, does the cost of this structure offset the cost of vehicle collisions and maintenance on the roads and animal removal and things like that, to the point where it's feasible to have these structures there from just a monetary value, which like, say what you want, but that is how the world functions, is around money. So it's got to have some sort of purpose in that means. And if you can communicate that it has a purpose to offset that through meta-analysis like this, then you're more likely to get these structures built, which then will, of course, help conservation. It's kind of like you have to trick the money-hungry people into thinking they're saving money, when in reality, you're just being a lot smarter than them about conservation, and they can just wallow in their money pits below you while you take a much higher, more purposeful stance above them. So you can think of it that way, is that if you're thinking that the people in power with money are better than you, you're just smarter than them.
Well, and in the perfect world, we are saving money and saving lives. Like everybody that does know me or has gotten to know me through this podcast or my Instagram knows that I'm like a huge conservation nut, but I know that a huge part of that strategy needs to be like working with the people with the money. So for one, yes, we're smarter than them, but hopefully people are saving money and we're saving lives. We're doing the conservation.
Right.
Right. So let's get into the paper. So I was lucky enough to talk a little bit with Dror Denneboom, who is the author of the paper. And just because I emailed them asking for a copy of the paper, which we talked about in one of our snips about ways to get access to papers. And the super exciting thing was not only did they answer me, but he also listened to one of our episodes and was super excited for us to go ahead and use this. So thank you, Dror, if you're listening. And I hope you like how it turns out. I feel a little bit under pressure here, but it's okay. The other cool thing that they pointed out with me is that to mention, the wildlife crossings leaders of the world are kind of Canada and the Netherlands are sort of the two countries that are heading up a lot of the research. But the really cool thing is over the last 50 years, there has been a huge increase in wildlife crossings all over the world. People are really trying to put the effort in to have crossing structures of all kinds in all different kinds of places. So if you guys go ahead and Google like wildlife crossings, there is a huge variety. There's these giant ones over Banff. There's ones for crabs on Christmas Island. There's these ones for turtles under railways. It's like all shapes and sizes, anything you can think of. So this is my personal experience with these overpasses on the Trans-Canada Highway in Banff National Park in Alberta. And there's these 6 huge overpasses that were actually built in 1978. So it was like quite a while ago, and it was kind of one of the pioneers of this. So that is something neat to also look into if you're digging the WCS knowledge. All right. So then for this episode, there's so many different great papers, but I just picked this specific paper because it's really nice and recent. And the meta-analysis is really attractive for, making a summary of a summary for our episode. So they go ahead in the introduction and they start with some of the same ideas that I brought up with about wildlife and human safety, conservation, and how there's a lot of information on what makes a good wildlife crossing structure. But so far, this is one of the first actual meta-analysis that's been done to bring this information together. So it's a pretty exciting paper. Now, they found to start 270 studies that they were going to use, but they actually had to cut out 161 because 161 of these studies measured the crossing of animals, but were not able to consider the animals that approached the structure. Now, I'm going to break down why this is important. So if you think about a little deer comes up to this wildlife structure and it sees the bridge and it's like, nah, that looks sketchy, and it leaves. This is an issue, and this doesn't measure effectiveness. So as difficult as it is to try to both calculate approach and crossing, they decided for the purposes of their paper that they needed to only use papers that used approaches and crossings.
Just to break that down, so I make sure that I'm fully understanding this. So essentially, the reason they couldn't use those specific papers that didn't consider that is because although certain crossings may have had, let's say, a higher amount of crossings, it doesn't necessarily take into account the overall density of animals that are approaching that bridge and utilizing it. Therefore, if a bridge has, 6 times the amount of animals, but only 1/6 of those animals cross, it might match up with, a different place where it's more effective at crossing, but a higher percentage of those animals from that other area cross. So without having the knowledge of which animals are being refused to it, you don't necessarily know the effectiveness of that bridge, because it could just be a numbers thing at that point. You need to know how many animals are approaching it and actually utilizing it, not just encountering it by chance and running across it that way. That doesn't necessarily mean that the bridge is effective. It just means that it was right in the way of where those specific animals were moving and doesn't take into account the faunistic densities of those areas.
Exactly.
Right?
Thanks, Nicholas. Yeah, that was a really good way to clear up a little bit more what I was saying. Exactly. To look at effectiveness of something, you need more percentages, right? Like you said, if it's 1/6 of the higher density, it's still less effective than an area with lower animal density where 50% of the animals cross, right? So, and of course, the authors really did note throughout the paper that they understand kind of the resource restrictions to being able to do both approach data and crossing data, because with crossing data, you can just have, one good wildlife cam or a couple, or there's these really cool things they use with that pick up tracks on ink of small mammals and herps and that kind of thing. But to track approach as well, you either need a lot more wildlife cameras or you need GPS data. It's super complicated. So they totally mention that, but for their purposes of the study to look at true effectiveness, we need the percentage of animals that are crossing after approaching. Yeah. But 77 studies, still a pretty solid number compared to, a paper looking at, one set of data. So then when they get started, they define 3 types of wildlife crossing structures. We have underpasses and overpasses, which are pretty simple for most people to understand, right? And then we also have a viaduct. Now, this one I was like, what the heck's a viaduct? I didn't even know. So instead of just being a small arch of like concrete that animals can go under. This is more like the ground is in a U shape, the road is over top of the ground, and then there's pillars there. So an underpass would be all concrete with a space to go through, and a viaduct is more of a U shape of the ground with the road kind of over that mini valley. And then there's just like maybe one big column in the middle to hold it up. Nicholas, does that make sense?
It's like a tunnel versus just an open bridge structure, where a tunnel could either be, I mean, I guess I don't know enough to say that one would be more effective than the other. Maybe the study looks at that, but because a tunnel might attract certain animals because it's out of the direct thing, light like that, but then it also might repel other animals just because of that. So I wonder if there's like variations that could contribute to, you know, where like
you're on a good hunch here so far. So
okay, yeah. Well, then I will let the professionals do it better than my hypothesizing.
No, you're doing great, honestly. Also, if anybody is craving an actual visual, this paper has a graphical abstract, which is starting to be more of a common thing as well, where people put like a really nice graphic summary of what they found. And I am actually going to post this as well on Instagram so that everyone can check it out. And it has the three sort of different structures and then some of the different findings between all of the different animal groups that they looked at, because they looked at a bunch of different ones. So just writing it out is a lot of work, but this graphic is super neat. So that will be there. Anyway, so they take all this data together and looking at the literature to narrow their approach, and they get to work. So the 6 functional groups, the animal groups they used are ungulates, large carnivores, small non-carnivores, herpetofauna, and macropods. And I always forgot what macropods are. Those are like kangaroos. So things like that. Anyway, so
that's weird. They didn't do any cetacean crossings?
No.
Oh, that's a shame. And you guys might be wondering, why is this restricted to animals? Why aren't there any plant bridges? Well, plants can't use bridges.
I mean, technically, like vine plants can use bridges.
All right, whatever. Let's ruin my joke.
All right. Okay. That'll teach you to be sassy. Actually, it won't.
No, it won't.
They won't. Anyway, so they had some expectations, and I'm just going to give them to you guys here. So they thought that wider and shorter crossing structures would be more effective for most species groups. Now, I'm pretty sure the thoughts behind this are just, it's like, you know, you have more space to get across, but you don't have to cross so much road, right? So it's kind of like, just get across and that's it. This is just expectations. They also expected that fencing would make the structure to be used more, which I think is fairly common sense. Like if a fence sort of funnels things to the structure, they follow the fence and then they go across. That's the idea, right? And then that viaducts and overpasses would be more effective than underpasses for large species. So kind of like what Nicholas was saying, like maybe a big underpass or viaduct would be good for something like an elk that likes more open spaces. And then maybe something like small mammals like mice actually like things that are tunnelish, right? Because it helps them to hide. So they were saying for large species that these would be better. And then this one as well is that structures that were built for both humans and wildlife would reduce how much they were used versus structures that were built exclusively for wildlife. Now, this is just that human presence makes less animals, essentially. Because there is some crossing structures that, for example, in a national park, maybe there's like a bike lane and people can use that to cross the highway. And then also the wildlife could use it. But they think that the human presence would reduce that.
That would make sense.
Yeah, that would make sense. I mean, all very clear, really great expectations. And here we go. Now, if you guys want to get down and dirty with the methods, please go check out the paper. But for our purposes, I'm not going to lean too much into it because it's going to get a little confusing and it's going to take up a lot of time. But it's a really super great paper. And I know that Mr. Denneboom worked very hard on it. So go ahead and check that out if you have the time. And then we get to get into the results, which is
also I don't know. I know you mentioned your gratefulness to the the specific author that you had talked with, but I'm very appreciative of that as well. I think that's really good, because that's one thing where I lack. I never approach the authors just based on I don't necessarily have the time to do so. Not saying you do, but you do take the extra amount of time to do that. And I think that that's something that kind of sets us apart. And I'm lumping myself in with you now, but sets us apart from other things is if we can't get the abstract of something. And also, like, there are websites that are sometimes you can access things that are pay to access without paying them, without going into too much detail about that. But they're not always reliable, and they might not always have the paper you're looking for. And a lot of times they're down because they're not what most people would be considered to be legal. So the alternative is reaching out to the authors. And many times the authors are very responsive. Not to say that I do it frequently, but when I do, I pretty much always get a message back, and they're very excited. So I'm always appreciative of the authors for providing us with more information and just a personal sort of look into a paper, because there's, just reading a paper, we can misinterpret something just based on how it's written, or by, not knowing or having as an experienced background as the authors have. So it's really nice when they're able to communicate with us and just allow us to, get a better insight into their paper, to communicate the science that they've done. Because we are science communicators. We're doing our own science, but we also have to communicate that. But it's a lot of times we're communicating other people's science, and it's very helpful when the people who have actually done that research can contribute to it, because obviously we're just communicating it. It's without going on too much longer of me babbling, I'm very appreciative for anyone who is very helpful to us, because it's just a really, really nice thing, and people don't do nice things very often. So it's a very nice thing for when researchers reach out to us, and we're very grateful for that.
Right. Well, and for our lovely small but growing fan base as well, stay tuned for a potential longer journalism piece I'm hoping to get out of this. So there might be some more details coming from Dror and some other scientists in the area. So this is just kind of a teaser trailer.
Woohoo!
Potentially. Awesome. Well,
coming soon to a podcast near you. We're going to keep that voice crack in there too.
Thanks, Nicholas, for that nice note. And it's always good to know that people are always more willing to collaborate than you think they are, I think, most of the time. Of course, you'll get rejected and ignored sometimes. But yeah, the nerd community is a beautiful community. Okay.
True that.
To the results. Awesome. So, of course, there are varied results for each functional group. Now, this paper just has a huge, beautiful, a little bit messy, like, they didn't do it in a messy way, but they didn't present it in a messy way, but bunch of data, because there's a whole bunch of different things. And they pulled from Clevenger et al. 2009. Dr. Clevenger is a really famous biologist that works on wildlife crossing structures in Canada. But essentially, he said, like, we have to understand that species are going to automatically move through landscapes that are more like their natural habitat, right? I mean, seems pretty clear. But so that means that, if we're making these structures, we need varied natural habitat to cover varied different functional groups, right? So, yeah. So things that match their preferred habitat, this is not the same for everybody. So I'm just going to quickly mention just a couple of the examples of what they found and go from there. So viaducts appear to be the most effective overall for large mammals in particular. So they're almost 3 times more likely to cross with a viaduct than an overpass, and like 3.6 times more likely to use a viaduct over an overpass. So we get viaducts are better than overpasses, which are better than underpasses in general for large mammals. However, the viaducts need to be dry, which is interesting. So if you get a big creek that starts running through this area because it's like in a dipped area and it's in the rainy season, it seems really difficult to cross for a whole bunch of things. So there needs to be other maintenance around for drainage that helps it be just a nice little dry area that they can get through. Because if they're coming up to this viaduct and it's just a raging river, they're obviously not going to cross it because that's not comfortable. Then also, probably as expected, the wildlife crossing structures that are made just for wildlife and not for people are more effective. And they found this was especially true for large carnivores, that they really needed to avoid people at all costs. Fencing really depended on the structure being used. So for underpasses, it worked really great for a bunch of different animals. But for overpasses, it seemed to lessen the amount of carnivores that used it. So I don't know if carnivores are just like deterred by like to follow a fence until they reach a point that they can cross, but really interesting anyway. And ungulates do not like long crossings, which kind of makes sense because they would have to like be worried about being trapped on one, right? So there's this like predator prey instinct, but it works pretty good for small mammals. And yeah, also just to accentuate how much predators avoid overpasses that are used for people and wildlife, predators would rather go through a drainage culvert than use an overpass that is used by both wildlife and people. So this is how much we need to make sure that wildlife crossings are strictly used for wildlife crossings, because I think they used an example of a jaguar or it was some kind of big cat, and they would cross through these drainage culverts and never use the overpasses that were both wildlife human related. So crazy. Anyway, and there's a whole bunch of other really cool stuff that everybody can go check out, which is really interesting. But the main takeaway that applied in general is that, of course, it's better to have as much natural material as possible. Things that don't look anthropogenic. Obviously, if you just have a huge steel structure going across the highway, it's not going to work. So there has to be native vegetation. There has to be, especially for small mammals, little like logs and rocks they can hide in and underneath and behind. And it needs to just not look like a giant steel bridge, which is maybe seems obvious, but hey, it's nice to have the numbers, right? And a great point from the authors, which I'm going to just read verbatim from the paper, is our systematic review showed that while much of the research effort in this field is important for understanding local trends in wildlife usage of WCS, the ability to draw broad conclusions from these studies is limited. So they're saying that it's just so hard to draw general statements about what's a good crossing structure, because you're going to have different functional groups. You're going to have different factors on how busy the highway is, on what the natural area is around it. Like, for example, in a boreal forest, you're going to need a ton of trees. But in the desert, a ton of trees is probably going to scare away the animals and the trees are going to die. But you know what I mean? So they're saying this study was great, but at the same time, it's really, really difficult. And local research needs to be done. Super important.
Right. You can't just have one bridge that encompasses all habitats. They're going to have to be different based on the flora and fauna that exists there. I mean, that's pretty straightforward, but, it's important to support that some way. So.
Right. Well, and it's just good to know, this study still really helped to kind of see where the gaps were and also to know where to start. Like, for example, if you're a biologist in an area that has 0 wildlife crossing structures and you need to come up with a proposal for the first couple before you start monitoring them, you have a baseline, right? What does work? What kind of shapes work? What kind of is fencing normally good or bad? And then go from there. So it's still really important to have these kind of studies. Also, we're missing a ton of data for herpetofauna and small mammals and stuff because they are really hard to track. And all the focus has been on our beautiful our charismatic ungulates and large carnivores. So we need to study a little bit more of the little guys. And then also we really need to find a way to standardize the sampling methods across all this different research so it's easier to put it together in the future. All right. So at the end of the day, no one size fits all, but this paper helped to kind of pave the way for people researching this for the first time, implementing it in a new area, and to understand what we're missing in the research and what we need to focus on more. So the last point that they made that I really loved is that this investigation and this research really needs to be invested in because it's going to help save costs later down the road, right? So you're making more effective ways to save both people and wildlife, saving money for, not building unnecessary parts of the structure, on how to maintain it the best. And so it's invest in the science and the research now and save the money later. So we're missing some information, but the study did a great job of seeing these gaps. And I just want to say wildlife crossings are so cool. And it's such an interesting topic to me. So thank you, Dror, for a wonderful paper and letting us feature it on our podcast.
We appreciate it.
Awesome. See you guys later.
Bye.
Thanks for listening to this episode of The Anthropocene.
Be sure to follow us on all social media and feel free to reach out to us with any comments, corrections, or suggestions for future episodes or species you'd like to see us cover.